Right. Okay. So where we're at right now with the class, we are just going to go into the slideshow here just a moment to talk about the different levels of measurement. And so for your first assignment, I ask you all to take a look at that to see what I'm asking for you to do. You're just making up data and making up variables and filling in the numbers, but you want to follow the criteria so that you're creating variables that are nominal, ordinal, interval, and ratio. And you can have any combination of those you want, just so long as you have a variable representing each one of those categories. Today, so we're going to go over that today about how we satisfy these different levels of measurement. There's just a limited number of different ways you can measure something. And this is true across all of the sciences. It's not just limited to social sciences, which is a good thing because there are billions of different types of variables you can measure, but really only a very small number of ways that one in practice does classify how these things are measured. Okay, before I do this, before I go to the lecture slideshow, is there any just general questions about anything at all, anything that you're having issues with about the class, about registering again, just, kind of basic administrative stuff, or about this class in particular? Okay, and remember, you Mac users, you will have to, unfortunately, rent a copy. I think that the cheapest one I can find is $39.95 a month for SPSS that will work on Mac, PC. You should be able to get into SPSS 4.3 through Apps Anywhere. But okay, so what we'll do, I'm going to go ahead and talk about this thing. Somebody give me a thumbs up if they can see the PowerPoint presentation. Okay, great. So yeah, so let's, actually this is the second slide. I want to go to the first. So there are only a limited number of ways that variables can be classified, which is a very good thing because it makes our life easier. The first type of way that a variable can be measured is what's called a nominal variable. We made one of these already in class. What state were you born in? Another example here, what is your gender? What is your race? What is your favorite color? These are all considered nominal variables because the numbers associated with them are purely arbitrary. They don't mean anything. You don't have more or less of gender. You have a gender. You don't have more or less of race. You have a race. You don't have more or less of a state you were born in. There is a number associated arbitrarily with the state that you were born in. And so with nominal variables, all the number indicates is that you belong to some certain category as the variable is described. It means nothing more. So there's, we could recode male here happens to be coded 0 as male, female is 1. We could recode it as male is -99 and female is 1,000. It doesn't matter because you're not going to be doing any statistical operations on these variables that would make sense of the values themselves. The values themselves are completely arbitrary. And so nominal variables are the kinds of things where it doesn't make any sense to ask the question, well, how much of this do you have? Nominal variables don't lend themselves to that kind of question. They're just numbers indicating membership in some group. That's all they mean. So when we're talking about nominal variables, it's just usually the frequency or the percent of your sample that belongs to certain groups, like what percent is white, what percent is black, what percent is male, what percent is female. But you would never present an average gender. You wouldn't present an average race, nor would you present like an average state that somebody is born in. That doesn't make any sense. And so nominal variables, you can't really talk about averages. You can talk about what's called the mode. We'll get into this in a couple of days. This is one of the measures of central tendency. You could say, well, what is the most frequently given response when you ask about what state someone was born in? Or you could say, what is the most frequently given response when given a choice of racial ethnic categories? So you could ask that kind of question, but it makes no sense to report on the median gender or the median race or average race or average gender. Those statements just don't make sense. And so for nominal variables, we're pretty limited, at least initially when we do descriptive statistics, on what kind of statistics we can use on nominal variables. Okay, so that's nominal. So you have to make a nominal variable for your assignment. And so this gives you some examples, your book gives you some examples. The next level up in measurement, it's something called ordinal measures. So ordinal measures, the numbers really do indicate more or less of something. And so depending on how it's coded, usually the higher the number means more of something, one means less of something, but it all depends on how it's coded. So one example that I use as an ordinal measure, this is a little bit dated now, but it's talking about Obama's health care law will be good for our future. And this is still debated, right? Where you have, this is called a Likert type scale item, a Likert item. And so you have a 1 being strongly disagree, all the way up to a 5 being strongly agree. And for each point up, what the respondent is indicating is how much they agree with that statement. And so it doesn't have the kind of precision where you know exactly how much more someone agrees or disagrees. You just know there is some rank ordering sensibility to this, that it makes sense why you would say someone is more in agreement if they scored a 4 versus scoring a 1 on this scale. You don't know just with what precision how much more, you just know it's more. Another type of ordinal type scale is a lot of times sports ranking. So a team might, one team might be ranked number 2, another team might be ranked number 3, but you know well that team number 2 is so much better than team number 3 that the ranking can be a little deceiving, because you'd think they would be some perfect interval that much better if you would assume it's like a ratio or interval measure. But with sports rankings, you can see that all they're doing is based on their the difficulty of the season and their winnings, where they rank in relationship to other teams. But some teams, like my team, Ohio State Buckeyes, got absolutely crushed by Alabama in the championship game, and I think Ohio State was 3rd and Alabama was number 1. But really, the difference, that one difference in the ranking between them didn't really indicate how much better Alabama was over Ohio State. So rankings, all that really tells you is that there's some level of a higher endorsement or some level of a better ability, indicating that's indicated by the numbers, but not much more than that. The problem here with ordinal measures also is that they don't have equal intervals. And so consider educational achievement. 1 is never attended, 2 is less than 8th grade, 3 is 8th to 12th grade, 4 is graduated high school, 5 is some college, and a 6 is a 4-year degree. But you can't really say that the difference between 4 and 5 is the same as the difference between 1 and 2, because they're not equal intervals. Ordinal just means that the number above or below is higher in some degree of measurement than the one below or above or below it. It doesn't. You cannot say that a 2 and a 3 are separated by the same amount of whatever you're measuring by a 3 and a 4. Okay, so that the numbers do have meaning. It's not completely arbitrary like nominal, but it's the kind of the lowest level at which we can conclude that a higher number really does mean more of something. In this case, you're approving of a president's policy or educational achievement. If educational achievement is measured in unequal intervals, then it's not. So never attended, is a different thing than saying an amount of years, because 8th, 12th is a more specific thing than never attended. So those 3 though is higher than a 1, but it doesn't tell you exactly how much higher. Okay, and so with ordinal measures though, it does make sense at this point. You can start reporting a mean or an average. Okay, so it would make sense. You can make sense out of, if you would look at the average response to the healthcare question, if someone got a 2.5 on that, that would suggest that they are somewhere, the average respondent is somewhere neutral to agreeing with Obamacare, because they're 2.5, because or I'm sorry, that would be somewhere between strongly, it would be somewhere between disagree and neutral. And so people between a 2 and a 3, you got 2.5, that the average person is somewhere between disagreeing with it and standing neutral on it. So you can get a sense from the sample as a whole what the average response is for a Likert type item, what the sample as a whole is telling you. And then on the 4.5 on the education question. So a 4 is graduated high school and a 5 is some college. And so if the average score for that item is 4.5, that means that the average person in your sample has somewhere between high school education and some college, right? Okay, so you are given at least that level of precision with ordinal measures where it makes sense at that point where you can start reporting an average. And typically the way these measures go is whatever qualities nominal has, ordinal has those qualities too, plus more. So it's still, you can still with ordinal measures, of course, you can say, okay, what percent of people in our sample said that they strongly agree with Obamacare? You can do that. You can say, well, what was the most common response? That's the mode. You can still do that. You can do that, which you can do with nominal variables. Plus, you can also talk about things like an average. Because an average level of educational achievement in my sample is 4.5. And you can look back at the original scale and say, okay, well, that means the average person in this sample has this level of education, roughly speaking. So you have to, it's always approximate because with ordinal measures, you just don't have the level of precision with some of the higher levels of measure. Okay. So the next level up is we have what's called interval measures. And so an interval measure, there is equal distance between the scores or between the numbers, but it's just a true zero does not exist, or it does not equal a total absence of whatever thing you're trying to measure. So the Fahrenheit scale, as well as the Celsius scale, are considered interval measures. Because the difference between 10 and 20 degrees is the same difference as between 80 and 90 degrees. They're both exactly 10 degrees difference, but it's not considered the next level up was considered ratio. It's only interval because a true zero on a Fahrenheit scale does not really exist. There is a zero on that scale, but it does not mean the total absence of heat. Okay, so if you remember from 8th grade physics, that true zero, it only exists on something called a Kelvin scale where there is no molecular movement whatsoever. And so that on a Fahrenheit scale, zero does not mean no molecular movement. It just means it's really darn cold outside. There's still molecular movement. Otherwise, if you walked outside, you would freeze to an icicle in a microsecond. And so trues, there's no, you're not really a zero on an interval scale does not really mean a total absence of what you're measuring, or a true zero may not be able to exist. You may not be able to, it may not make any sense to say that there is zero of something. So you can't have zero height. You have some height, you can't have a true zero. It doesn't make that, it doesn't compute, doesn't make any sense. So interval measures, all they are is that each step up is the same distance as the last step up from the previous level of measurement. But true zero really doesn't exist on interval measures. This makes the most sense when we're talking about Fahrenheit and Celsius scales, where zero is just the freezing point for Celsius, zero is just really cold for Fahrenheit, but it doesn't really mean a total absence of heat. It means something else. It just means it's just cold. So the appropriate stats that you can use on this, you can look at the means, the medians, the modes. These all make sense to report. That's all interpretable with regard to these interval measures. Okay. Now the last one, there's just one more, and the one more is what's called ratio measures. Ratio measures have all the same qualities as interval measures, except for the fact that true zero does exist. So example from physics, the Kelvin scale, A 0 on the Kelvin scale means there really is 0 molecular movement. Molecules are not moving at all. So there really is absolutely no heat. There is no heat whatsoever detected. This goes on just way out in deep space, away from all stars. I don't know if physicists ever really found a truly measured true 0, but it's theoretically, it's said to exist. Income is another more straightforward one. You really could be totally broke. You could have absolutely no money in the bank, and that $0 in your bank account, everybody's probably been there at one point. You know what that means. So that means a true total absence of any money in the bank. But the difference between $1 and $2 is the same thing with the difference between $2 and $3. It's a $1 difference. Okay, there's a clearly defined interval there. That also there's a 0 in the scale, and so that means that you're at the ratio measurement. And so for ratio scales, they are the ones. These are the types of measures where it makes sense. You can report an average or a mean. You can report a median and a mode. And so these are all meaningful statistics with regard to ratio measures. And that's it, folks. That's the different ways, the 4 different main ways that variables can be classified into those different types of measurement. All right. Are there any questions about that? These different types of levels of measurement? Because yeah, we want to probably move quickly here to SPSS, and we just want to generate some of these ourselves. So let me stop sharing here for a second. I want to go to my SPSS, and I already have this thing opened. So what I'm going to do, I want to open up that data set that we were building previously. So whenever you open up SPSS, you want to find your old data, you want to go to File, and you want to go to Data. Now, just I'm taking a moment to point this out because this happens a lot when people are first using this program. They'll go down to syntax, they'll go down to output. Those are different file names. They're totally different file names. We won't be messing around with syntax file, but we will messing around with the output file because that's where it shows your results. But for opening up a new data set that shows like a spreadsheet, you want to go to new data, and then you just have to find wherever, I have to share this again, wherever that was, actually I did that wrong. Sorry, let me, File, sorry, let me get back to this. Sorry. Okay, try this one more time. File. New is opening up a brand new data set. I made a mistake. You want to go to where it says open. New is creating a new data set, which we did already. Okay. Open, go to open, and there is that again. There's where it says data. And so you go to data, and now I have to find where I save the thing. Okay, and it should be, I believe it's in my documents. Okay, so I'm going to this my first data set .sav. It's called the SAV file is the name of the data file. And just double click on that, and that should open up here. All right, and so here is, can everybody see this, the spreadsheet where it says age and state up here? You can't see that? Okay, let me try this. Okay, so you should be able to, can you see that now? Okay, so yeah, so I went to File, I went to Open, and I went to Data, the data icon, and then it opens up the window, the file finder window, and then you can go and find wherever you saved your data set. Okay, so we're here. Okay, so we made already, age, and so this would be considered an interval scale. True 0 is not on here, but the difference between 20 and 21 is 1 year. That's the same difference between 19 and 18. It's a 1 year difference. So that's an interval scale. We made this variable called state, and now state, we can remember if you go and click this thing, it shows you if you put value labels in there, This is just nominal because a nominal scale, the number associated with the group category is just purely arbitrary. And so that's a nominal variable that we made. I want to make another nominal variable for you, just so you remember how to do this. And so if we go to where it says down here at the bottom of the screen where it says variable view. And so the variable view, if you click that, it'll go to this screen. Okay, and this is the screen where we can input characteristics for our variables. Okay, so let's, we can create one, I'll call it marital status. Again, remember, for when you're making variable names, you cannot have any spaces or any special characters in it, and it limits the number of characters you can also put in there. And so I'll put label, I can also put a label in here. I can put a space in there. It also allows me just to write more. Marital status, and I put that in as a label. And if you recall, yeah, label, it's much more flexible. When you put a label in, that's where you can put a longer description, and you can type even a little paragraph into that spot if you want. But typically, you're just labeling it, so you want to give yourself a little bit more information. Here, we don't really have to. I'm just calling it the same thing because there's no need to put any more information there. Here is what's called, what's called the value labels, and this is where we need to come up with numbers that are associated with our nominal variable. So we'll say 1 is equal to married, and I'll put that in and add. And then we can say 2 is equal to, let's say, divorced. Oops. Wait, let me, let's give me a little error here. Let me, 2 is equal to, that's why I was doing it backwards. 2 is equal to divorced, and then you always have to hit add, and it adds in there. There you go. We'll say 3 is equal to, let's say, separated. Okay, and then 4 would be equal to, let's say, widowed. And then we can say 5 is equal to never married. Right. Okay, so we have, this is a nominal variable, and 1 is married. We could have made 5 married. It doesn't matter. 1 is married, 2 is divorced, 3 is separated, 4 is widowed, and 5 is never married. So I totally just made up the numbers for that, and it's okay. I could have put in -99, 17, 4, 13, and 1 billion. It doesn't matter. All you're doing, you just need to create numbers associated with these group categories for nominal variables, because the numbers themselves don't have any inherent value. They're just markers. They're just numerical markers for these categories. And we go ahead and hit OK. And then we can go back and we can fill in. So we can say this person, we'll have this person be, what was never, somebody remind me, what was never married? Somebody tell me what I put that as. Is that 4? Or is that?
I think it was 5.
Okay, I'll go back and look at it. We'll put a lot of these people never married. Okay, now never married was 5. Thank you very much. All right, so yeah, so we'll go back. We'll say 5 for this person. Oh yeah, here we go. Right here we go. Well, 5 never married. 5 never married. Put a couple 3s in here. That's separated. 3 separated. We'll put a 4, a 1, a 1. And then the rest of these, we'll put 1 widow, and then we'll put the rest of these never married, never married. Now it's automatically popping up as the value labels because I haven't unclicked this thing. If we go back to that, it's just showing the numbers again. Okay, so this is a nominal variable. If we want to make an ordinal scale, so the ordinal scale, we'll use a Likert item as the ordinal scale. Now, sometimes you hear people saying this is an interval scale, but I don't like that. I like to call Likert scales ordinal items because we don't know exactly how much endorsement how much differences endorsement is going on between approval of something on a Likert item. So we'll say this is we'll go Biden approval. We'll say Biden approval for the variable name, and let's make a label for this. See, how much do you approve of Biden? Question mark. Okay, so if we expand that out a little bit, how much do you approve of Biden? Then we have to, we're going to code this in a typical Likert style. So you want to go ahead and click this, and you want to go ahead, we'll say strongly disagree, add. 2 is just disagree, add. 3, typically there's a neutral spot on Likert style items, add. 4 would be agree, and 5 would be strongly agree. Oops, what's this? Okay. Strongly agree. So, 1, 2, 3, 4, 5, strongly disagree, disagree, neutral, agree, strongly agree. And we hit OK. And then again, we can go back and put, we'll put a couple people that love them, a couple people that hate them, a few people in between, a 4, and a 2, and a 2, and then somebody else who loves them. All right. And so for your assignment, you're just making up numbers that still, though, fit within the range of the variable that you created. And so that would be an example of an ordinal type measure. Okay, so let's make one that's ratio. So for the ratio variable, you could say, what was the one I made up? Okay, so let's pretend that these are all people that were in the workforce since 18, and they've all been in the workforce for at least 1 year. So interval measure, we can say years in workforce, and I'll make a label. Years in the workforce since age 18. All right. So we'll go ahead and hit that and hit this. Yep. Okay, and so for this, we'll say a 1 is, we'll say that's 1, 2, 2 years. Add that. So we want to make them even intervals. So 2 then would be we'll make it non-overlapping. 3 to 4 years. 3 would be 5 to 6 years. And then we can just leave it at 4. I'll stop at 4. 4 would be then 7 to 8 years. And then we could always, I know there's going to be some people, well, why did I put that if I had, 2.5 years? We could always give additional instructions on the survey. It says, well, round down to the nearest full year of work. And so people would say 2.5 years. Okay, then I'm in category 1. You could always give them extra instructions. But here we have 1 to 2 years is the same difference between 7 to 8 years. It's you're talking about a 1 year interval. Okay, so it's always going up in the same amounts, measuring the same amount. And so we go ahead and put okay. And then we would go back again and we can start, putting this in. So we can put, put a 2 here, put a 2 here, we can put a 2 here, put a 3 here, put a 1 here, put a 1 here, 2. No one will end up having a 4. It's okay. You don't have to use the full range of your scale if it doesn't make sense with the year. So I notice I have a 17-year-old in there. And so we'll just go ahead and put a 1 in there for this person. And this is whenever you're looking at data and you notice something like that, well, this person is saying employed since age 18. There's a 17-year-old in this study. This is a case where you may have to end up throwing out this person data because you assume that all your samples, all your respondents were at least 18 years of age, but you got an 18-year-old in there. And so when you have something like that that just doesn't jive with reality, that's where it's called data cleaning, and you have to go through and figure out, well, which cases are giving information that we really can't use because they're not even old enough to qualify to answer this question. And they just responded to it because they had to put something down because they're trying to fill out your survey. So whenever you see something like that, that's when you're later on when we analyze data, sometimes you have to decide to throw certain cases out because they just don't fit. But for our purposes right now, all we're doing is trying to establish that we can come up with variables that fit into the categories of nominal, ordinal, interval, and ratio variables. So years in the workforce, that pretty much satisfies the criteria for interval measures. Okay, and so then you could also have a ratio measure, and you could say, let's say, earnings. We'll call it earnings right now, and then we'll define what that means more specifically in the label category. Let's say last year's earnings to the nearest dollar. All right. And so this will be a ratio measure because you can have somebody last year, this person said, I wasn't employed at all. I earned $0. This person said, I earned 16,000. This person, 22,000. Again, 19,000. Just making up numbers here, folks. It doesn't really. Wait, that's 190,000. This person's really rich. Okay. We'll put 13,000, 14,000. And there's 16,000. I'll put somebody 15, 5, 0, 0. 12,000. That's 120,000. Oh well, doesn't matter. And then we'll put 10,000. Okay, and so earnings would be a ratio variable because the difference between $1 to $2 is the same difference between $3 to $4. It's a $1 difference, but a 0 on the scale really is meaningful because you could have somebody who truly didn't earn any money in the previous year, so 0 makes sense. It really means a total absence of earnings in the previous year. Okay, folks, and so yeah, that is where I would like to stop today. And so your job for your assignment is just to come up with 10 variables. You need to have at least one nominal, one interval, one ratio, and one ordinal in there. Okay, look through your book. Feel free to Google and to come up with examples, but just look at the criteria that I put on that slideshow, and make some stuff up. This is just a matter of you making stuff up. So long as you adhere to the criteria, then you're good to go. Remember, ratio, a true 0 really does need to make sense on your scale. It's like it's either the zero, it doesn't occur, but you could say, well, it's still ratio because you potentially could have a zero score on this. You could still then count it as ratio. But a zero really does have to be statistically meaningful. It really does have to exist. So like, for example, someone cannot have a zero height. It's not, unless you're talking about preconception or something like that. Even if you're a little cluster of cells, there's some measured dimensions in that thing. So yeah, I would classify height as, it would have to be interval. It can be a true zero on height. But other things, yeah, if the true zero is there, then it's ratio. If true zero does not exist, but it's even intervals. Difference between 1 inch, 1 inch and 2 inches is the same thing between 3 inches and 4 inches, a 1 inch difference. Okay, but then you want to do a nominal one, and those are just arbitrary. And then you want to do a ratio one, or I said ratio, interval, and then ordinal one. There are any kind of like rankings where you have a like or type item, that would be ordinal, or if you have anything that has unequal intervals, but each time you go up a number, it does mean more of that thing, then you're ordinal. Okay, if it's unequal intervals, but every time you go up a number, it means more of that thing, then it's an ordinal variable. But if it's equal intervals, and every time you go up one, it means more of that thing, then it's interval measure. And if that interval measure has a true zero on there, then it's a ratio measure. All right, folks. So now is your time. We've got about 20 minutes left, or no, about 10 minutes left actually. For any questions, if anybody wants to screen share or anything like that, we can do that. I can make you a co-host. Just it's time for you to speak up if there's anything that you're not getting at this point. I can stick around for a few minutes after class with people if they need it, but this is it. This is what you got to do. You just got to, after you do this, you have to go to File, and then you want to go to Save As, and you want to save your data set somewhere. Make sure that you save your data set. And that you are making sure that you save this .sav file, and that you're not saving the output file, which there will be an output file. Let me know if you can you guys see this little window that popped up? Okay, let me stop sharing. Let me go back, because it will generate an output file for you. That's not the one you want to save. So you want to go here. It will have generated this screen right here. You can see that now, can't you? Where it says, yeah, it says get file C- from my computer. That is called the output file. So when we come to save our results, you have to save this thing separately. So File, Save As, and I'll just show you. It comes up as something called an SPV file, which is different. So you don't have to deal with this time around. This is for future assignments where I don't want to see your data set. I just want to see the output file. But for now, oops, let me exit out of that. But for now, you just want to save that .sav file, the data file. Okay, folks. So yeah, that's it. Are there questions about anything? So what you want to do, again, you want to upload to Moodle this little data set that you created. That's what you want to upload to Moodle. And I will just check to see if you did it. If there are questions that you have, and it's not occurring to you right now that you actually have a question about this, and you want to email me later today, that's fine. You can do that, but it is due tonight by midnight. And I think that you all should be able to do this. Just remember, you want to satisfy all those criteria. You want to make 10 variables. It doesn't matter how many nominal you have in there or whatever. You just need to have each one of those kinds of variables represented in your data set. Okay, there's other columns in the variable creation window that we didn't mess with. You don't have to worry about that stuff yet. We will deal with that later. But all you're doing right now is just basically doing what we did in class today. Just don't use my examples. Gotta come up with your own. You can make a Likert item if you want. That's fine. you just don't use the Biden one. Just do something else. Just show me that you can make a Likert item. Okay. Anything else, folks? Okay, if there's nothing else, you are free to go and go ahead and complete this thing, upload it to Moodle, and that should be all. I will see you all Wednesday, and we'll start with the recoding exercise. We're going to do recoding on Wednesday, how to recode variables into different variables. All right. Okay, folks. Take care. Hopefully this goes off without a problem.
I do have like a quick question, but it's just about one of my variables.
Okay.
APA be considered an interval one?
What is APA? What is that?
A GPA, like the grade point average, would that be an interval variable?
Well, I would rank that as, I would classify that as ratio, because someone could really have a 0 GPA.
Okay.
You know, you could have, that's possible, right? It rarely happens, but if you get all Fs in your first semester at college and you have no other, you will have a 0 GPA.
Okay.
Yeah, so that's interval. Just the regular thing, the regular grading scale, you could have it as interval, so long as it's defined as you could have it defined like a 90 to 100, 10 points. That's a 10-point difference. It's the same as 80 to 90. That's 80 to 89 is the same amount difference. Like you could do that, and that would be interval. And so long as the 0 doesn't really exist on there. So okay. So
thank you.
You're welcome.
Bye.
Bye-bye.